In this next video, we're going to look at some variations of the parent graphs for sine and cosine wave, and we have this definition for amplitude, period, and phase shift. So take a minute, pause the video, and you want to copy these formulas down because we're going to use them in the rest of the video. So when given the format y equals a sine bx plus c, or for the cosine as well, when the b is greater than 0, our amplitude is defined by the absolute value of a. That's why in the last video I said it's always positive. The period is 2 pi over b, and the phase shift is negative c over b. Also, we want to make note of if the a term is negative, then the graph will be reflected about the x-axis, so it would justify a reflection. Okay, before we get too precise into the specific shifts or period changes, let's just intuitively look at this in the respect of transformations and the stuff that we've done prior to this lesson. If I looked at this and I could see that in here I have my parent graph is the sine of x, so that would be this one in red that's dashed. This is a parent graph, okay? And we're trying to say, well, what happened? What did they do to the graph of y equals sine of x minus, this looks like pi thirds? Okay, well, how did we get from this parent graph to the solid black graph? What did we do? Right, we shift right pi over 3, so you can see that this means shift right pi over 3, and that is, remember when we had that in transformations, that's consistent as well. Okay, what about this one over here? So if we look at our parent graph, remember the dashed one's the parent graph of cosine, and I tried to figure out what's going on here by looking at this equation, what would you suggest? We shift to the left pi fourths. Okay, so we even have a good idea of what's going on even by just by our knowledge of transformations. Okay, so now let's just practice with, we have y equals 3 sine of x. So the first thing they want to know is, well, what is the amplitude? Well, the amplitude by our definition was absolute value of a, right? What is the a in this particular equation? 3, good. So it's the absolute value of 3, which our amplitude would make it just 3. So basically, it's our sine wave, our parent sine wave with an amplitude of 3. So now let's decide which one of these is the correct answer. Keep in mind the dashed line is your parent graph. So which one looks very similar to the parent graph but has an amplitude of a 3? Well, this one's opposite of the dashed line. This one's doing the other thing. So it's really just already a 50-50 guess between A and D, right? What does the amplitude look like of this one if I was to go over? We can see which one's at 3. Clearly, it's going to be option D. Okay, now let's look at y equals negative 3 sine of x. We don't have any other shifts going on over here, so it's basically a parent graph comparison, and we have negative 3. So first of all, our amplitude is what? 3, or the absolute value of that, our absolute value of negative 3, which is just 3. So we have an amplitude of 3 again. But what does that negative tell us that we have to do? It's going to be reflected. Good. So that means let's determine which one of these graphs is the sine wave with an amplitude of 3 reflected about the x-axis. Well, clearly this amplitude right here is much higher than 3. And this one as well. So which one of these has an amplitude of 3 but it's reflected? B. Good. So option B. Okay, let's move this a little further. So now we have y equals 4 sine of pi x. So that might be hard to see. So A is the 4 and our B is pi. Okay, remember the formula on the previous page. Whoops. Sine of bx, isn't it minus c? Okay, plus c. Let's determine an amplitude. So if we look over here, what's our amplitude? 4, so it's the absolute value of 4, which is just 4. Alright, now the period. Let me move that out the way. The period is calculated by, we recall from our formulas, the period is 2 pi over b. Okay, so 2 pi, what is our b in this particular example? Pi. Good, so it's 2 pi over pi, and then that simplifies to just be 2. Good, so our period in this example is 2. Alright, now we want to go and look at these graphs and identify the one that has an amplitude of 4, that's similar to the parent graph of sine of x, amplitude of 4, and a period of 2. What's the period of this one? 1. What's the period of this one? 1, so eliminate those two already. So it's either between C and D. Which one is similar to the parent graph of sine? D, yes, because it starts here and goes up. You can see the other one went in the opposite direction. So yes, we're going to have answer choice D. Okay, now we're going to have one with a phase shift in it as well. I'm going to pause it for a minute and label this, and I want you to give this a shot to see if you can name your amplitude, name your period, name your phase shift, and then select the graph that matches your information. Okay, so I jotted down some information you may use. Now plug in your information over here and calculate those and find the graph. Okay, well, amplitude's fairly easy. The amplitude is just going to be, there's a known 1 there, so absolute value of 1 is just 1. The period is 2 pi over b. What is b in this particular example? 2. So when this 2 simplifies with this 2, you just have a period of pi. Okay, and our phase shift we want to calculate, which is our c. So negative c divided by our b, which is 2. Okay, so if you want to algebraically multiply by the reciprocal, you would just get negative pi fourths. So our phase shift is negative pi fourths. Okay, so which one is shifted to the left pi fourths, has a period of just pi, and an amplitude of 1? Okay, first let's eliminate things that don't have a period of pi. This has a period of pi. This one is 2 pi. We can automatically scratch that one. Now this may seem a little bit confusing, but if you were talking about just distance, from here to here is pi fourths, and from 0 to here is 3 pi fourths, what is that period? 1 pi fourths plus 3 pi fourths. It's still a period of 4 pi over 4, which is pi. So these two have the correct period. So now let's find the one that shifted to the left pi fourths. Looks like both of these are. This one has no shift at all going on. So now determine between B and C, the parent graph of a sine function. Yes, B is a reflective one. Good. So that leaves us with C. Okay, let's do some cosine. Negative 2 cosine of x. So pause it and take a guess. Okay, good. Amplitude of a 2. It has a reflection. So if this is the parent graph, the reflected one, because it's hard to see down there, would be this. And we're looking for the one that has an amplitude of 2. So, good.